All right. Welcome everyone to today's demo about the AerMet model. Today I will present an overview of the AerMet model. I'll first talk about what that model is and what it does, and then the kinds of data processed by AerMet and the process stages. I will also briefly talk about the air surface model, which is tied to AerMet, and then we'll go through an example modeling exercise. And again, today's demo is an overview of the AerMet model. So the AerMet model is the meteorological data processor for the AirMod air dispersion model. It processes certain meteorological data files, which I'll go into later in this presentation, and creates two files for AirMod, something called a boundary layer parameters file and the profile file. And the latter file has information about wind speed and direction recorded at one or more levels or one or more heights above ground. And it might use both of those files for its processing. And since AirMod processes, since AirMod calculates its outputs on an hourly basis, these meteorological data files also contain data on an hourly basis. So there's one record per hour of data that you've processed in AerMet in the output files. I'll show an example of what that looks like at the end of the example, when we do the example model run. So AerMet creates a meteorological data file for AirMod that AirMod then uses. And there are actually several types of data that AerMet can process, and the first one is surface data. That means hourly surface weather observations. And in the United States, these observations are usually made at observation stations throughout the airports. At airports located throughout the United States. This data in the United States, at least, the data has been provided by the National Climatic Data Center. In other countries, it may be provided by the governmental authorities of that country. But at least for the United States, we do have files going back for the past several decades, and since 1995, this data has been recorded in the ISHT format. And that's the format that we'll use in our example modeling exercise as well. And down here at the bottom of this slide, I have a link for where the surface data can be downloaded for the United States. It's from the NCDC. So that's the first type of data. Next, we have upper air data. And these are observations collected twice a day at midnight and noon at Greenwich Mean Time. And they're collected at multiple levels above ground. Now, upper air data for recent years, which I think are since about 2000, are recorded in FSL format. Older files are in the TD61 format. And here I also have a link for where you can download the upper air data files for the United States. And actually, in the United States, if you're processing that data, then you will need to download the upper air data for one day more than you. For example, if you process it for for the year 2012, you'll actually need to download data for January 2012 to January 2013. The reason for that is that they collected at, say, midnight Greenwich time will actually be collected at 7 p.m. the previous day in the Eastern time zone, or 6 p.m. in the Central time zone. And there will be several hours for which there's no corresponding upper air data at the end of the data period that you're modeling. So if you're modeling in the Western Hemisphere, not just in the United States, you need to get upper air data for one more day than you're actually going to process. And we'll see that in the example model run as well. Now, surface air data and upper air data are commonly used in AerMet model runs. And the next kind of data that AerMet processes is the on-site data, which is not as common. But what that is that it's data recorded in an estimated tower that's located at the facility for which you're running dispersion modeling with AerMod, or very close by that facility. And the difference with this data and the previous two that I mentioned, there's no standard format in which the on-site data files are recorded. So if you do have this kind of data, then you need to provide both the data format to AerMet and the format in which the files are recorded and the format in which the data are recorded in the data files. And in our example modeling exercise that we'll do a little bit later, we will not have the on-site data. And finally, we have and the final type of data that AerMet can process is the hourly wind data. And what's happened there is that since about 2005, observation stations, definitely in the United States and possibly in other countries around the world, have been recording wind speed and direction at that site every minute. This is fairly accurate. That's according to the nearest degree from which the wind is blowing. And now the 1 minute data is not directly, instead the AerMet model, the AerMet model is run to create a file that AerMet can use, which has the hourly average wind speed and direction. And we'll actually cover AerMet in another webinar next week. It is optional to use the hourly wind data. You can either use it or omit it. But if you do include the hourly wind data files, then if your surface data have any missing hours, or if they have columns, then AerMet will read information from the hourly wind data file and will substitute for missing data in the surface data file. So once again, those are the 4 kinds of data: the surface, upper air, on-site, and hourly winds. Now, AerMet actually processes the data in 3 stages. The first of which is the data extraction and quality assurance. AerMet will read all the files that you have provided to it, and will check the data, see if it can read it, and see if there are any errors in it, or to see if there are any values that are out of the expected range. If it does find if it does find any errors, it will report the errors to you in the output files. Then for stage 1 AerMet, just make sure that it can read all the files that you've supplied to it and does some quality assurance steps. The next stage is called stage 2, and that's where AerMet creates a single file that has all of your data inside it in 24-hour blocks. So then just takes all the one or more files that you supplied to it and puts all that in one file called the merge file. That just has 24-hour blocks of data. And finally, stage 3 is the final stage, and that one creates the metadata files for AerMod. And typically the two files have the .ssc extension for the boundary layer file, the first file, and .pfl for the profile file. And the first file, the boundary layer file, has several pieces of data, including the ones on this slide, such as wind speed, relative humidity and temperature, surface reference length, and others, all of which AerMod needs to calculate the concentrations. All right, now, what is also needed at stage 3, when the data files are created for AerMod, is that AerMet needs to know the albedo, brownish, and surface reference length values for the location that you're processing. If you have just surface data, these values are needed for the surface location. If you also have on-site data, then you need the values for both the on-site location and the surface location. And there are actually a couple of options. If you know the values, you can enter them on your own, but what is typically done is that typically the Air surface model is done to calculate all the values for you. You know, either on your computer or on one of our servers, and I'll show that step as well in our example modeling exercise. But typically the air surface model is run to calculate these values based on land cover data for the site that you're modeling. All right, so now we'll have an example modeling exercise. In this case, we're processing the data for the year 2012 only for the whole year. And we're going to include the surface and upper air data files, but not the hourly wind files. So now we'll go ahead and switch to our AerMet program, and we'll go through all the steps here. So on the main step screen, okay, so on the main step screen, we select the data files. We have data files that we'll use in the modeling exercise, which is just the surface and the upper air. Selecting the local air surface, meaning that air surface will be run on my computer. Also, very importantly, we tell AerMet which dates to process. In this case, and then we're going to process the year 2012. And before we need one extra day at the end of that period, so we'll actually go through January 1st, 2013. And also in our AerMet GUI, in our program, the hourly winds files, the hourly wind data files are called AerMet data. But we don't have that in this example. this modeling exercise. So for the surface station, I need to supply it a file with data, which has already been downloaded. So the format SHD. The time adjust is how many hours away is the data from the Greenwich Mean Time. In this case, this modeling exercise involves a station in Asheville, North Carolina, which is 5 hours behind the Greenwich Mean Time. So here set the time just to 5. We also have to enter the location where the surface data were collected, and also the height of the station above sea level. Similarly, for upper air data, we have developed the file format, which is FSL, where the file is located on my computer, and the time adjust, and also the location of the station. And also for the quality assurance, you can clicking the Set K Values button allows me to tell AerMet which values I want to check during the first stage of the data extraction stage. Now I'll just go ahead and stick with the default values that it will check for us. There's a temperature, wind speed, and wind direction. AerMet will check that those values are within the expected parameters. So for this exercise, I'll just leave the modeling defaults alone and continue. Okay, so now we have the surface data file, upper air data file. We've specified our station locations. Now we're ready to tell AerMet where to write the output files. I'm going to select the 2012 file and save. And we can continue. Now the next step, we're actually going to set a couple of options used by air surface. First of all, how many wind sectors do we want to process? In this case, it's going to be 12. And how frequently do we want it to report our albedo, bound ratio, and surface roughness? In this case, it's going to be once a month. The options here are once a month, once a year, or seasonal, which is spring, summer, autumn, and winter seasons. So go ahead and continue with the settings as they are here. And go ahead and run air surface. Now air surface has an additional data file that you need, which is the land cover file, which has already been selected. Which I've already downloaded and which has been selected here. I do need to tell air surface the location for which to calculate our values, the surface albedo ratio and reference. And once that's been input, I can go ahead and say run air surface. One more thing is that I am saying that the site is at an airport. Oh, okay. So I think I said it wrong. And you select this file in a different folder. right to your own air surface, and then the air surface will calculate all these values for you, which AerMet will need for stage 3. Now that we have all that, we have our input files, we have the output files, we have the results from air surface. Now we can go ahead and run AerMet. Now we are ready to run AerMet. Okay, so now it's running stage 1. And now that that's done, I can actually go and take a look at this messages and see if there were any errors or warnings from our data extraction or QA. I do see a few warnings about wind direction missing or calm winds here. But it doesn't look like there are any errors here. I'll show you look at the report output file. I can scroll down to the bottom and see if there were actually any errors here. And there were just a few warnings here for this modeling run. So now that stage 1 is completed, we'll go to run stage 2 to create that output file. And that was successful as well. And finally, we'll run stage 3 to create the files for AirMod. And again, we actually run this for January 2012 through January 2013, but we actually want the data for January 2012 through December 31, 2012. And there are no error messages here. So I'll go ahead and click this button at the bottom of the screen to remove that January 1st, 2013 from our output files. Now that's so let's just take a look at what those files look like. So this is the profile boundary file, and as you see, it has one record per hour. So this is actually January 1, hour 1, 2, 3, 4, and so on. And has about multiple parameters for each hour that has been processed. And then the profile file is structured similarly, where it also has information about information for every hour that has been processed. So that's the end of our presentation on AerMet. I'm going to unmute everybody in a minute, and then if there are any questions, you can go ahead and ask questions.